In this project, I was responsible for predicting daily bike rentals using a linear regression model. I used Google Colab to complete my analysis and predict how many bikes were rented every day over the span of 2 years. First, I loaded in the necessary libraries for all the code I wanted to run. If I didn't load all these libraries in, I would not be able to make the graphs I needed or generate a linear regression model. Then I loaded the CSV file in that had all the bike data, and I saved that data in a data frame called df_bike. Next, I calculated the dimensions and found that the data had 731 records, or rows, and 14 columns. I did this by using the shape feature in Google Colab. Then I previewed the data with the head function. In the year column, 0 represents 2011 and 1 represents 2012. The months were ordered from 1 to 12 and the weekdays are ordered from 0 to 6. 0 represents Sunday and 6 represents Saturday. The seasons are also represented with numbers. For the holiday column, 0 means the day was not a holiday and 1 means that it was. The same applies for working days. 1 represents Monday through Friday and 0 represents Saturday and Sunday. The weather indicators are temp, atemp, hum, and wind speed, and those numbers are normalized. 0 represents the lowest value and 1 represents the highest value. The last 2 columns are regarding the rentals. Casual rentals refer to people that rent the day of their ride and don't have an account for whatever reason, and registered rentals refer to people who are registered with a bike rental system and most likely rent every day or frequently. Then I created a new column called total_rentals, and it was the sum of the casual and registered rentals. I previewed the data with the head function and calculated the dimensions again. Notice how there's 15 columns now instead of 14 since we added the total rentals column. I also generated descriptive statistics for the columns in the dataset using the describe function. This allowed me to see the count, mean, standard deviation, minimum, and maximum values for each column, as well as the values for the interquartile range. I also created a pivot table with the year and month as indices, and that sums and averages total rentals. Then I determined if there are any missing values in the data set with the isNull function, and found none. Next, I moved on to generating graphs. I generated a histogram to visualize the distribution of data in the total rentals column. I also generated a scatter plot with casual rentals on the x-axis and registered rentals on the y-axis and color-coded the dots based on whether it was a working day or not. I also generated a swarm plot with season on the x-axis and total rentals on the y-axis. I generated a line plot with the month on the x-axis and the total rentals on the y-axis. Finally, I also generated a pair plot to show the relationship between total rentals and all the weather indicators, which include temp, atemp, hum, and wind speed. Then I created a new variable called bike_heatmap. So I can create a heat map and show the correlation between the total bike rentals and the weather indicators. For the last portion of this project, I needed to generate a linear regression model that showed the relationship between the independent variable, the weather indicators, independent variables, and the dependent variable, total bike rentals. I only included independent variables that had a correlation coefficient with respect to total rentals that was greater than 0.5 or less than negative 0.5. I did not include atemp since it was highly correlated with temp and thus not independent. Because of these parameters, I only had one independent variable, which was temp. I separated the independent variable, temp, from the dependent variable, total rentals. Next, I split the data into training and test sets using the train_test_split function. I then fit the linear regression model using the training data and printed the intercept and coefficient. Following these steps, I predicted how many rentals the company would have in one day if the temperature of that day was 0.3 normalized. Finally, I found out that they would have 3,267 rentals that day, rounded. Finally, I predicted that the total bike rentals in the test data and saved the prediction in a variable called y_predict. At the end, I generated the R-square value, which turned out to be 0.75 rounded. 0.375 rounded. The R-squared value indicates how much variation of a dependent variable is due to the independent variable or variables in a regression model. According to this R-squared value, the variation in total bike rentals is not explained very well by the temperature for any given day, but there is some variation.